Hello, class. I'm going to do a recording for you for Chapter 10, Section 6, the graphing chapter, and it's called Graphing Linear Inequalities in Two Variables. And so it's on page 193 of your course workbook. And so I'm going to share my document camera with you now. Okay, so the first page is a lot of vocabulary. And remember, when you take your test, I do allow you to use the first sheet. Sometimes it's the first two sheets of your lessons because they have notes and instructions. So this one would be the first page. So we go over some of this definition, which you'll also do in your Learn. You want to be spending 15 minutes in your Learn. Also about 30 minutes, or at least 30 minutes on your practice. And then you have your homework completion, right, in the certify part, right? And so, but you get 5% of your grade is calculated from the time that you spent in the Learn and in the practice. So as long as you're spending about 15 minutes in the Learn and at least 30 minutes in the homework, you shouldn't have an issue accumulating the time needed to earn 100, which is going to be 5% of your course grade for that, okay? So half plane, they define it as a straight line separates a plane into two half planes. 2 points on one side of the line are in one of the half planes, and then the points on the other side of the line are in the other half plane. Okay. Boundary line. The line itself is called the boundary line. Okay. Closed half plane. If the boundary line is included in the solution set, then the half plane is said to be closed. Open half plane. If the boundary line is not included in the solution set, then the half plane is said to be open. Okay, so usually what happens is when you graph these linear inequalities, you're going to create either solid lines or dash lines, dash broken lines. So the solid line has the underscore in the inequality, you know, less than or equal to, greater than or equal to. There you would require to make a solid line. But if you just have less than or greater than, then you're going to use a dash line. Okay, so when you talk about the detail of your solutions set, you're going to have a lot of different numbers, different points as solutions. If you have a solid line, those points on the solid line will also be included as part of your solution set. If you have a dash line, any points on that dash line must be excluded and not be included as the answer as part of the solution set, okay? And then you will have to do some shading. You either shade above the line or below the line. And so usually you let the inequalities guide you. If you have something, if you have an unknown y, right, is less than or equal to some line, less than or equal to, that means you want to shade all your inequalities, your solutions to your inequalities are below the line. You want to shade below the line. But if you have y greater than or equal to the inequality, the line, then you want to shade above the line. So that's kind of how that works with the shading. And of course, when you have x's and y's in your inequalities, those are slanted lines, right? So if you have the involvement of x's and y's in an inequality, because it's not an equation, these are not an equation, these are an inequality, then you're going to have some kind of a slanted line. It might be dash, it might be solid, but it's slanted. If you have only x's or only y's in your inequality, remember that's when you have either the vertical line or the horizontal line. Okay, so just remember that if you have only one variable in the inequality, like for example, if you have only x's only in the inequality, then that would produce some kind of a vertical line. And if you have y's only in the inequality, then that's going to form some kind of a horizontal line. So remember, my advice for you on these, when you have only x's or y's, is that you use a little generic table. Remember we talked about this? And your book will not provide that for you, but you, when you do your homework, you should draw a little generic table to get a feel for the points when you plot them. So if you have only x's, x is always something. If you have only y's, y is always something. And then you pick the other values under 10, 10 or negative 10 to get some ordered pairs, and then you plot them. And you'll either see a vertical line take shape or a horizontal line take shape. So vertical lines look like this, or it could be broken, right? Dash. Horizontal lines look like this, or it could be dashed, right? If it doesn't have the underscore, it could be dashed. Let's keep that in mind. Okay, then at the bottom, we have some more vocabulary. Graphing linear inequalities. First, they want you to graph the boundary line, and they have here dash if the inequality is less than or greater than, solid if the inequality is less than or equal to, or greater than or equal to. So I kind of mentioned that already. Next, determine which side of the line to shade using one of the following methods. So they give you two methods. So method one says that you would test any one point, obviously on one side of the line. So you would test some x, some y. And when you test it, you would use the original inequality. And you're going to substitute. You're going to substitute. So you're going to pick a point on one side of the line and then substitute those points. I usually try to pick something on what I think is the shaded side. So you pick a point, substitute it. And that's called a test point. So if the test point satisfies the inequality, if it satisfies it, that means it's going to be true. Then you want to make sure you shade the side, the half plane on that side of the line. Otherwise, you're going to have to shade the other half plane. So you only want to shade sides that are true. You only shade sides that are true in the inequality. Now, when you pick a point, you want to make sure you have to be careful with your line if it's solid or a dashed line or solid line. When you pick a point, if you have a dashed line, you don't want to pick a point off of a dashed line because those, remember, are not part of the solution. So usually when you test any point, you do want to pick something that they say that's on one side of the line, not necessarily like on the line. Try and pick something that's on the right side or the left side. Try to stay away from picking points that are actually on your line, because you could have some difficulty determining if it's a true inequality, if it's actually a point on a dash line. So just keep that in mind. Then there's another method. Well, they do say something about the 0.00. If it is not on a boundary line, is usually the easiest point to test, because when you work with zero, anything times zero is zero. So that's true. But again, they say if it's not on a boundary line, as long as it's not on a solid or dashed line, they say you can use 0, 0. That's the easiest point to use. Method 2, you would solve the inequality for y, assuming that the line is not vertical. Because if it's vertical, then you won't have any y's. See, if it's a vertical line, you're going to have only x's. So then you'd have to solve for x. So you solve the inequality for y, assuming that it's not a vertical line. If the solution shows that y is less than or y is less than or equal to, so less than or equal to, then you want to shade the half plane below the line. Okay. If the solution shows that you have y is greater than or y is greater than or equal to, then you want to shade the half plane above the line. Okay, and we'll show you some examples of that. Note, if the boundary line is vertical, then you want to solve for x. Okay, and then if the solution shows that x is greater than or x is greater than or equal to, then you want to shade the half plane to the right. But if the solution shows x is less than or equal to, then you want to shade the half plane to the left. Okay. And then the shaded half plane and the line, if it's solid, not dashed, is the solution to the inequality. So you have a solution set, you have all the points that satisfy the inequality, that when you plug them in, they always give you true statements. Okay. All right, so this will make more sense once we do some problems. So if you're still writing, go ahead and like pause the frame and write this down if you're still writing. But otherwise, I'm going to just continue with some problems. Okay, so let's go to the ones that the math department made. Remember, you always have these extra graphing paper, these extra grids to help you. Okay, this is also, if you want to pause that, and that's in red, that helps you read that. You can pause that. This is in red. It shows up a little better than what I had in the black and white. Okay, here are some problems. Okay, let's start with these. So the math department created about 6 problems. Okay, so let's go over these 6 problems. All right. So of course, always read the directions, always read and follow the directions. Graph the solution set of each of the following linear inequalities. Okay, so you have x plus 8y is less than or equal to -8. Okay, so what you want to do is, because you have x's and y's, you know this is going to be some kind of a slanted line. You also know that there is no underscore, it just says less than. So you also know this is going to be a dashed line. So these kind of things you want to make a note of, that you have a dash, slanted line. And that's because that's dash because there's no underscore, and slanted because you have both x's and y's in the inequality. Okay. And what we want to do is we want to go ahead and start solving this inequality for y. And the reason is you want to mimic, y equals mx plus b. So I know that we don't have an equation, we have an inequality. We don't have an equation, but we can still graph, because we have to graph the line. We can still use ideas from slope-intercept. This is called slope-intercept form to graph our inequality. So remember, to do this after we solve for y, you have to plot your y-intercept, which is 0b, which is your 0 and your constant. Okay. And then after you plot your y-intercept, so 0 tells you to stay. And then depending on b, you're either going to go up or you're going to go down, or if it's 0, then you're going to stay, right? Depending on what b is. But you first plot your y-intercept, and then you honor your slope. And when you honor your slope, you're using this idea of rise over run. So that if you have a positive, you are going up, positive numerator. You have a negative numerator, then you're going down. And on your running, if you have a positive, then you're running right. And if for some reason, if you have a negative, then you're running left. Usually you rarely have a negative on the bottom. Usually teachers train you that if you have a negative in the middle of your fraction, you just push it up to the top, apply it to the top. So you rarely have a negative on the bottom. You're usually running right anyhow, okay? And you want to do those moves, slope moves, you want to do those moves from your 0b, from your y-intercept, okay? So those are ideas. Those are ideas from section 10.3, I believe. So we get to skip 10.5, but here we are in 10.6, needing to rely on math concepts that we learned back in 10.3. So math is linear, it does build on itself. So this will give you another opportunity if you're not if you need more practice, if you're not so comfortable with the lesson from 10.3, this will help you because you need to know that lesson. These graphing, we're graphing not using a table. We're not graphing using a table. We're graphing using a slope intercept form. So this will help you reinforce that. So to solve for y, you want to isolate your y. So you have the 8y and the x. First, you should use opposites and move the x over by adding opposites. So the opposite of x is the take away x, minus x. So then you have 8y is less than. And here, it does matter what you put first. You're trying to mimic mx plus b. Notice how they put the slope first. You should put your slope first, which is a negative 1x. And then you should put your constant. B is your constant, which is a negative 8. Now, the book usually doesn't write 1 anywhere because it's so trivial, but for what we're doing, we do write the 1, the negative 1, imaginary 1. We will write it to help us graph, okay? And then to finish solving for y, you're going to divide by 8. So I just want to remind you that if you had had a negative 8, you would have divided by negative 8. Just remember that the inequality would have changed. The direction of the inequality changes whenever you divide or whenever you multiply by a negative coefficient or negative number. So I'm going to make that comment up here. I'm going to say that when we divide or multiply, an inequality. Yeah, so this doesn't happen when you're working with an equation. This happens when you're working with an inequality. So remember, these are inequalities. See these less than equal to, greater than equal to, less than, greater than. When you're working with inequality, if you find yourself dividing or multiplying by a negative, and I'll just call it a coefficient, then we must change direction. of the inequality. Okay. And I think maybe what I'll do in one of these problems, I would probably make one of these negative just so we can practice that. Because if I remember correctly, I don't think when the math department gave us these 6 problems, I don't think they have that so that we can practice that. So I will probably make one of these somewhere a negative y so that we can change that. Okay. And I'll probably do it. I'm not sure which one I'm going to do it on, but I'll probably do it on number 4. That's what I'll probably do. Okay. All right. All right. Okay. So moving along, we're going to divide everybody by 8 in 3 chunks. So first, what we did was we added opposites. Okay. Now we're going to divide by 8. So I'm going to divide this by 8, divide this by 8, divide this by 8. So you want to divide by 8 in 3 chunks as opposed to 2 chunks. The reason why you're dividing in 3 chunks as opposed to 2 big chunks is to see any reductions. That's why we do that. Okay. Okay, so then we have y is less than, this is just negative 1/8 x. And you see that negative, you might be written like in the middle of the fraction. What we should do is push it, to the top, apply it just to the numerator, because that's a slope. That's an mx. And you see, we need to get ready to do this rise. See, rise, you either rise up or you rise down, or you run right or you run left, right? So if your numerator is positive, you go up. If your numerator is negative, you go down. Then you hold your pencil, and generally we just run to the right usually, because usually the denominator is positive. So if your negative is in the middle, we just push it to the top. And you don't want to overuse your negative, because a negative over negative makes it a positive, right? Negative divided by negative is positive. You don't want to change your sign on accident. So this is a negative 1/8. So just apply the negative to the numerator, okay? All right, and then this can be simplified. This right here can be simplified. You want to simplify that. And a negative 8 divided by 8 is a negative 1. Okay, so I'm going to box that right there. And now you have y is less than negative 1/8 x minus 1. Okay. Now notice how you have the less than. Y is less than. When we graph a line, we're going to have to shade the side of it, one side of it, because this is saying y is less than. That means that we're going to have to shade below the line, because it's saying y is less than, here's your line, negative 1/8 x minus 1. And it's going to be a dashed slanted line. So all your y's are for your unknowns. The y's are unknowns, right? There are solutions, like our solution set. So all our unknowns are below that line. So you're going to have to shade below that line. So just keep that in mind. All right, now to graph it, remember, first thing we do is they say you have to plot the y-intercept. And remember, this is their y-intercept. See, y equals mx plus b. The intercept is your constant, see, 0 constant, and it's a negative 1. So your y-intercept is 0, negative 1. And that tells you to stay and to go down. So I'm going to do that here. Stay and then go down. That's 0, negative 1. Okay, that's your y-intercept. See, crosses the y-axis. That's your y-intercept. Okay, now next, we're gonna honor your slope. M, honor M, right? Rise over run. Okay, and you need a fraction. So there's your -1/8. So apply the negative just to the numerator, okay? The whole thing is negative, but just apply the negative to the numerator. This tells you you're gonna go down, down 1, and right 8. Down 1 and right 8. And you're going to do that movement from the y-intercept. So from 0, -1. So from 0, -1, you go down 1, out 8, down 1, out 8, down 1, out 8, depending on how much grid you have. So here you're going to go down 1, out 8. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like that right there. And that is the point. Looks like 8, -2. Looks like 8, -2. But you don't have any more grid to go down 1, 8, out. Again, you don't have enough grid. But you have enough grid in the opposite direction over here. So you know how we talked about undoing your slope? If you undo your slope, that would mean that instead of going down 1, you go up 1. And instead of going right 8, you would go left 8. So you could undo your slope, go up 1, left 8. So if I do that from over here, from the y-intercept, if I go up 1 and then out 8, 5, 6, 7, 8, about right here, that looks like it's -8, 0, which happens to be an intercept, right? That crosses the x-axis. That just happens to be an x-intercept. Okay. And then when I connect my line, I'm going to use remember we said we're going to use a dash line. And the name of this line, it's an inequality, is y is less than -1/8x minus 1. That would be the name of it. And remember, you have to shade. Remember, it's less than this. Your unknowns are less than this line. And here's your line. So you have less than means you have to shade below the line, not above it. Okay. And on the computer, when you do your homework, it'll have you choose, like, it'll have these like radio buttons, radio dials, and you just choose like how you're going to shade below, above the line. I'll have you ask you something like that. Okay. Now, as a check, what you should do is remember in your steps, they did have you do a check, remember? They had some about a test point, right? They said something about the test point. So what you should do is kind of check your work, is pick any point that you want, in the shaded region, and just try to pick something that's not actually on the boundary line. And I went ahead and they say that 0, 0 is the easiest point to choose. Okay. Which is right here, but it's just not on the shaded region. So if I choose something that's next easy, that's on the shaded region, if I choose like another intercept, like a 0, -5, because the next best thing to 0, 0 is to have at least 1 0. So if I pick 0, -5 as a test point, Okay, so I'm going to do a check. And I'm going to use 0, -5. And I'm going to substitute it into the original, substitute into the original inequality. So that would be this x plus 8y is less than 8. So everywhere I have an x, I'm going to substitute 0. And everywhere I have a y, I'm going to substitute -5. So I have 0 plus 8 times -5 is less than 8. So I have 0 plus 8 times -5 is a -40. It's less than 8. So now I have just -40 is less than 8. And you're like, oh, it's less than -8, excuse me. -8, sorry. Put your little negatives. Okay. Yeah, so is that true or false? So if I do a little sketch on the number line, let's say here's 0. So let's say -8 is here. And let's say -40 is over here. Yeah, and I would say that that's true. You know that numbers to the left are always going to be smaller, right? Is that what we learned in one of our notes in one of our chapters, right? That numbers to the left on a number line are always smaller. So -40 is on the left of -8. -40 is smaller. So this is true. This is less than. -40 is less than -8. That's true. So that means that you want to shade. That means you want to shade the side. Shade the side that has or that contains 0, -5. That's what that means. You want to shade the side that has the truth, right? 0, -5 was true. So you want to shade the side that contains 0, -5. So yeah, you feel comfortable with your work. You did that correctly. Okay. Now, if you want to make the math easier, like they said that testing 0, 0 makes the math like the easiest when you do a check. If you wanted to test 0, 0, you could, and then just know that it's not in the shaded region, so that means that you're saying it's false. So if you were to test using 0, 0 and you plug it in, you would get a false statement, and that means that you want to make sure you're not shading the side that contains 0, 0, because it gives you something that's false. You could do that also if you wanted to. So I can show you that here. If we do a check, and if we use 0, 0, as long as it's not on the line, it's not on the line. It's not. 0, -1's on the line, but 0, 0 is not. And then you just call that x, y, and then you use the original inequality. X plus 8y is less than -8. And then you substitute. Everywhere you have an x, you put 0. Everywhere you have an 8, 8y, 8 times y, you put a 0. So you see how that makes that math easy? See, anything times 0 is 0. So you have 0 is less than -8. So this looks like this. Here's 0. Here's -8. Numbers to the left are smaller. So this is saying that 0 is less than -8. And that's not true. That's false. Okay, so what that means is do not shade the side of the line that contains the point 0, 0 because it creates a false inequality. So that's bad news. You don't want that. You want truth, right? You don't want anything false, so that's not good. So you don't want to shade that side that contains 0, 0. So you see 0, 0 will be right here. You don't want to shade this side then, because that's false. So you could do that on your check then also. So just remember then, if it's false, you don't want to shade that side that has that point. Okay, so you could do that also. All right. Okay, so let's go to number 2. Okay, so we have 2y minus 5x is greater than 10. Okay, so again, in all these problems, you always want to solve it for y, okay? So this one I'm going to have to add 5x to both sides. 2y is greater than, and then remember which one goes first. You want to mimic, you're going to solve for y because you want to mimic y equals mx plus b. Okay, so see that they put the mx, the slope first, and then the constant. You want to do that. You want to put the slope, right now looks like it's 5x, and then the plus 10 constant. But we're not done yet. We still need to solve for y. So now I'm going to divide by 2. Remember we said that if you're dividing by a negative, if this had been a -2, then I would have had to change the direction of the inequality, okay? But we're just dividing by 2, so I don't have to change it. And I'm dividing by 2 in 3 chunks. So I have y is greater than 5 x. And then 10 divided by 2 is 5. 10 divided by 2 is 5. So we're simplifying it. Okay, and this is our answer. Okay, and notice how this is saying all are unknowns. These are our unknowns, right? These are saying our unknowns, all our solutions are greater than this line here. That means that you're going to shade above this line because all our unknowns are greater than this line. Okay. And on your line, you're going to need a dash line, a dash, or they call it a broken line. And the reason for that is because due to no underscore. Okay, a little underscore like that. Okay. All right, so now we're going to have to graph. So first, to graph, always remember you're going to have to first plot the y-intercept, which is 0b, right? Which is 0 constant, right? Which for you is 0, 5, right? There's your constant. And this tells you to stay and then to go up. So here you're at 0, and you go straight up. And that's 0, 5. Okay, that's the y-intercept. See, it crosses the y-axis. Okay, now you're going to have to honor your m, your slope, rise over run, and you need this fraction, 5/2. And slopes are always supposed to be reduced, and that's 5/2 is already reduced. We don't make slopes into mixed numbers. Don't say it's 2 and 1/2. We don't make slopes into mixed numbers because if you make it a mixed number, you don't have anything to call that whole number. You know, mixed number looks like this, and then you don't have anything to call that whole number here. So it's just a rise over run. So don't make it a mixed number, okay? But reduce it when possible. All right, so this is positive. So this tells you to go up 5. And then this is positive. This tells you to go right 2. And you're going to go that movement up 5, right 2 from the Y-intercept, from where you left off, from 0, 5. So from 0, 5, you're going to go up 5, which takes you all the way to 10, right? 1, 2, 1, 2, 3, 4, 5, up 5 and right 2. So my lines are kind of light. I don't know how your lines look like. Mine are kind of light, but I know to go up 5 means it takes me from 5 to 5. Another 5 is 10, and then right 2. So that is the point 2, 10, right? This is 2 right here. 2, 10. But I don't have any more grid, so I cannot keep going up 5, right 2, up 5, right 2. But I have a lot of grid down here, so all I have to do is undo our slope. So instead of going up 5, I would go down 5. Instead of going right 2, I would go left 2. So I'm going to go from here, from 0, 5, I'm going to go down 5. That takes me down to 0, right? And then left 2. See, that looks collinear. This point is 2, 0. Okay, then I'm going to go down 5, left 2. I think I went too much. Down 5, left 2. So I think that's what? -4, -5. Is that correct? And it looks collinear. And we're making a dash line. Not solid because there's no underscore. And then if I wanted to name that line somewhere nearby, I could call it y is greater than 5/2 x plus 5. That would be the name of that inequality. And don't forget about your shading. This was saying all the unknowns were greater than this line. So to show that they're greater than this line, you want to shade above the line. And I can show you where that's at in your little notes there, because you are allowed to use the first sheet. So I can show you where it says that. See right here on method 2, this part right here. So you see that like here says above the line, shade above the line. See if you have greater than or greater than or equal to. Whereas you have less than or equal to, you shade below the line. That's where I'm getting that from. So right now we shaded above the line because we had greater than or greater than or equal to. So we say we had the greater than. That's where that comes from. Down here, we shaded below the line, less than, because that's what this was, see, less than, shade below the line. Greater than, shade above the line. Okay, so these little underscores didn't come out too good, but they're there. So I darkened them here for the X's. Okay. Okay, so then let's do it. We should do a check. So let's do a check. Okay, so if you want the math to be easiest, the 0, 0 is the easiest point to use. And just remember that if we use 0, 0 to make the math easy on the check, remember how it should be false. This is not in the shaded region. So when we plug it into the original equality, we should be getting something that's false. So if you want to do that, we can. We're going to check. We're going to use 0, 0 to make the math easier. So x, y, and we're going to use the original inequality. 2y minus 5x is greater than 10. And everywhere I have a y, I'm going to plug in 0. And everywhere I have an x, I'm going to plug in 0. And anything times 0 is 0. And 0 minus 0 is 0. So see, it makes the math easier. And is this true or false? Is 0 a number that's bigger than 10? That's false. 0 is not greater than 10. That's false. So that means that don't shade the side that has 0, 0. Don't shade the side that has 0, 0. And we did not shade the side. We did not shade the side that has 0, 0. We shaded the other side because it's false. You don't want to shade sides that are false. You want to shade truth. So all of these are solutions. All these points in here are solutions. Now, the points on the dash line are not solutions. Like is -4, -5 a solution? No. So if I ask that question, is -4, -5 a solution in your solution set? You would say no. And the reason is because it's on a dash line. Okay, if it had been a solid line, then if it had been solid line, yeah, you include solid, you have a little underscore there, then you would have said yes. But no, it's a dash line, so no. Okay, but all these points, all these points are solutions to that inequality. Okay, there's a whole bunch of them. All right, let's do number 3 now. All right. So the purpose of 3, I think, is just so you can practice a lot of adding opposites and moving things around and remembering, because you want to solve for y. So I would see how y is on the wrong side. You want y when you solve for y, you want y on the left side. So I'm going to start by adding 3y to both sides so that I can move that over here. So now I have 3y plus 3x plus 8 is less than 8. And then now I'm going to move the 3x over, and then I'm going to move the 8 over. So now I'm going to subtract 3x. I have 3y plus 8 is less than, and I'm going to put the -3x first, and then I'm going to put the plus 8, because I'm trying to mimic y equals mx plus b, trying to put the x term first and then the constant. The x term first for the slope and then the constant. Okay, now I'm going to move this 8 over. I'm going to subtract 8 on both sides. So then I have 3y is less than -3x. And it just turns out that 8 take away 8 is a 0. So my constant is 0. And so that's okay. Sometimes that can happen. And now I'm going to divide everybody by 3. So y is less than, and this simplifies, right? A -3 divided by 3, that's just a -1x. And this also becomes 0, right? 0 divided by 3, and I can show you on the calculator. Remember, 1 is undefined and 1 is 0. This spells on, right? 0 whole number in, dispose on, right on, you can do that. That's a 0. I can show you. 0 divided by 3 is 0. It's when you have 0 on the bottom that it's undefined. So this is 0. Okay. And basically that's our inequality. And probably the computer will complain if you put the 1 and if you put the 0, it'll probably complain. It probably just wants that. That's what the computer probably wants. Okay, but on a paper pencil test, I'm okay with that, right? So now you need to plot your point, right? So the first thing you have to do is you have to first plot your y-intercept, which is 0b, the constant, which for us is 0, 0. Because see, the constant is 0. See, and the computer won't have you even type it in, but it's 0, and that can happen. That's the origin. That's right here. Okay, then you're going to honor your slope, m, and you know it's rise over run. You need a fraction, so it's a -1 over 1. Right? You need a fraction. There's a magic 1 underneath that. Okay. Okay, so this is telling you to go down 1 and to the right 1. So you're going down 1 and you're going right 1. And you're doing that from the y-intercept, which was 0, 0, right? So from the y-intercept, from the, in this case, the origin, you're going down 1, right 1, down 1, right 1. And that point is 1, -1. And then you just keep going down 1, right 1, down, right 1, down 1, right 1. You have lots of grid here. It's collinear. If you wanted to undo your slope, we would go up 1 and then left 1. If you wanted to undo your slope. And you would do that from over here, the top part over here. Up 1, left 1, up 1, left 1, up 1, left 1. Okay. And again, we're going to have to make a dashed line. This is saying that all your unknowns are less than this line here. Okay. And so this means that you're going to shade below the line. And you also have a dash line as opposed to a solid line because there's no underscore. Okay. So I think the computer will also have you choose a radial dial on there, dash line or solid line. Think of how you choose that. And the name of this line is y is less than -x. If I just put the least amount, that would be it. But this is also okay. Okay, that's also all right. Okay, and then we said we're shading below the line. Okay, so don't forget to do your shading. On the computer, you'll have to tell you're shading above or below, so don't forget to do that. Okay, and now we do a little check. And now here on the check, Notice on the check how we can't use 0, 0 and Y. It's because it's on the line. Yeah, so if it's on the line, and it's especially if it's dash, it's on the line. And what makes matters worse is that it's a dash line. So yeah, shouldn't use 0, 0. Use something else. So maybe you can use like if you still want the involvement of 0, you can get an intercept, or I mean, we'll just pick like something with, I should say, not pick an intercept, but I should say like pick a number from the shaded region and pick a number that will have 0 involved in it. So like, let's just say I pick on this -5. So that would be the point 0, -5, which is because it's got 0, you can think of it as a y-intercept, but it's not the y-intercept for this line because the line doesn't cross the y-axis at 0, -5. It crosses the y-axis here at the origin at 0, 0. In fact, it crosses the x and the y-axis at 0, 0. So really, this is the x-intercept and the y-intercept. But you're trying to choose a point and make the math easy. So to make the point easy, if you can't get 0, 0, if you can't use 0, 0, because this one's on the line, then you want to choose something that has 0 in it. So I'm just going with 0, -5. You could have gone with 5, 0, 5, 0, or 2, 0, or 0, 2. That's fine. I'm just going with 0, -5. I'm just randomly picking that out. And I'm going to substitute it into the original. 3x plus 8 is less than -3y plus 8. And everywhere I have an x, I'm going to put 0. Everywhere I have a y, I'm going to put 0. And that just makes the math easy because anything times 0 is 0. Anything times 0 is 0. So then I have 8 is less than 8. Is that true or false? That is false. 8's not less than 8. 8 equals 8. But I don't have a less than or equal to. It didn't have the underscore. It didn't say less than or equal to. It only said less than. So 8 is not less than 8. So that would be false. Uh-oh. That would be false. So if it's false, we should not be shading. We should not be shading that side if it's false. And we did. Okay, we might have an error here. Let me think. If it's false, we shouldn't be shading that side. We should shade the other side. Okay, let's go back. Did we make a mistake somewhere in the shading? Let's see. So we subtracted opposite 3y is plus y. So we added 3y, subtracted 3x, subtracted 8, divided by 3. Y is less than. So y is less than. So if it's less than, you shade below the line, right? So this says here, if y is less than me, see, shade below the line. Okay, so I think this is correct on this side. So maybe when I did a substitution, you're supposed to pick a point and then plug it in and see if it's true or false. And we want true. So let's see, we plugged in 0, -5 into the, maybe we made a mistake here, into the original equation. 0, 0, 8 is less than 8. Oh, I know what I did wrong. When I substituted, I was supposed to substitute 0, -5. You were using 0, -5. That's x and y, x and y. And I'm not supposed to be, remember, we're not supposed to use 0, 0. See, we said we can't use 0, 0 because it's on the dash line, so we shouldn't be testing that. See, because I guess an example that it gives you false information like fool's gold. We shouldn't be testing using 0, 0. It gives us false information because it's a dash line. You can see that's false, and so it's misleading. But what happened is when I substituted, I should have substituted x is 0 and y is -5. So right here for -3 times y, I should have had -3 times -5, which is a positive 40. So I have -3 times y, and y is -5 plus 8. So -3 times -5 is 15 plus 8. -3 times y, -3 times 5, which is 15. And what's 15 plus 8? Is it 23? 15, 16, 23. Yeah, it's 23, right? So 8 is less than 23. That's better because that's true. 8 is less than 23. So that's true. So then you want to shade the side. You want to shade the side that's truth. So you want to shade the side that has 0, -5. So you want to shade this side. And we did. Okay. So just be careful like that. Be careful. And so the error wasn't made here. The error was in the check. I was trying to do a check, and that's sometimes where the mistake can be made. Okay. All right. Okay. Now on 4, let's do this. Let's do an edit on number 4. And let's go ahead and make this a -7y. That way we can practice that idea whenever you multiply or whenever you divide by a negative coefficient, you have to change the direction of the inequality. Because on your homework, when you do your practice, you're going to have some like that, where you're going to have to change the direction. So let's do that. So here, to solve this for y, all we have to do is divide by the coefficient, and we changed it to a -7. And then you also want to make sure that you change the direction of the inequality. And that's the reason why you're doing that is because we divided by a negative coefficient. Okay, so I divide this by -7, divide this by -7, divide this by -7. And then this will just give me y, change the direction of the inequality. This will give me a -5/7. So see how this negative is down here? You have a choice. You can, when you do your slope, you have a choice. You can either leave it on the bottom. So then this would tell you to go up 5, and this would tell you to go left 7. You can do that. Or you can just push the negative straight up to the top. You can do that. And then this tells you to go down 5, right 7. So you do have an option. The whole slope m is -5/7 anyway, but on your moving, you have an option on that. And then over here, a negative divided by negative, that's a positive. And this can be simplified. This can be like simplified also, because 7 goes into 35 5 times, right? So that's positive. Negative divided by negative is a positive, right? So negative divided by negative is a positive. Okay. So it looks like we have this now. And we had to change the direction of inequality because we divided by -7. Okay. So you can have this, or if you want to leave the negative like this on the bottom, you could. Technically, if you wanted to do your movements, you could like this, okay? You could. All right, so let me use the first one. So using y greater than or equal -5,7x plus 5, using that, the y-intercept is 0, 5. So we stay and then you go up. So right here. Okay, then we're going to honor our slope, honor our m. And if I go with the top one, -5 over 7, if I go with that, this tells me then to go down 5, right 7, down 5, right 7, down 5, right 7, down 5, right 7. Okay, so I'll do that here. Down 5, 1, 2, 3, 4, 5, right 7, 5, 6, 7. So this is the 0.70. Okay, and I don't have enough down here grid to go down 5, right 7. Now, notice how if you're going to use the other one, y greater than or equal to 5 over -7 x plus 5. Notice here how your y-intercept is still 0, 5. But when you honor your m, your slope, you honor your m, rise over run, notice how this is 5 over -7. This tells you to go up 5. This tells you to go left 7. Up 5, left 7, up 5, left 7. And you would do that movement from the y-intercept. Okay, so from here, from the y-intercept, you would go up 5, left 7, up 5, and then left 7. This is the point -7, 10. So you see that when you're using this movement, then you see how you're using graphing the other side of that line there. But it's collinear, right? And notice how this is an underscore. Notice how this is underscore. These are going to be, this is going to be a solid line. A solid line. And this is saying greater than or equal to, greater than or equal to. So this is greater than or equal to, greater than or equal to. So this means you want to shade above the line because it's greater than or equal to, and that's what this says here. See, right here, greater than or equal to right here. Above the line. Okay, so then when I connect those, I'm going to draw a solid line and then shade above the line. Solid line And I'm going to use, it doesn't matter which one, I'm going to use y is greater than or equal to, it doesn't matter which one I name, I'm just going to name this one. -5/7x plus 5. And we're shading above the line. Okay, so let's do a check. If I do a check, I'll use 0, 0 because it makes the math easier. And according to this, when I plug it in, x, y, I should get a false statement. It's not on the shaded region. So when I plug it into the original inequality, -7y less than or equal to 5x minus 35, I should get a false statement. So -7 times 0 is less than or equal to 5 times 0 minus 35. So -7 times 0 is 0, less than or equal to 5 times 0 is 0 minus 35. So 0 is less than or equal to -35. Is that true or false? 0 is less than or equal to -35. That's false. And 0 is not smaller than a negative number. Okay, it's false. So that means that you do not, because it's false, you do not want to shade the side that contains that 0, 0. You don't want to shade the side that contains 0, 0 because it gave you something that's false. You only want truth. Okay. All right, so I just inserted a negative there to get some practice with us flipping the direction of the inequality. Okay, now let's go to number 5. There's 5 and 6, 5 and 6. Let me do 6. Let me do 6 first because it has x's in it. When you have inequalities that have x's and y's, like this has x's and y's, they're going to get slanted lines. But when you have inequalities that have only x's or only y's, you're going to have vertical, horizontal lines. And in our notes, we said that over here that if you have x's only inequality, that we're going to get a vertical line. And this one's going to be, see how it underscore, it's going to be a solid line. So this one, you make a note to yourself that this is going to be a vertical line, vertical solid, because see the underscore, vertical solid line. Okay, you have only x's, no y's. And so you want to remember to draw this generic table. You should remember that whenever you have equations or inequalities that have only x's, you want to draw a generic table for that. And here you are going to have to do a little bit of solving, very minimal. You are going to have to solve, but you can't solve for y. You can't solve for y. There's no y. So the next best thing is to solve for x. So you're going to add 5 to both sides. And x is less than or equal to 5. And so what we'll do is we will just insert 5. We will insert 5s because we want to draw a line. We do need to draw a line. So for the x, we're going to just say x is always 5, as if it had been any equation. So we just let x be 5. And then you pick whatever you want for y. So like I'll pick 0, and then I'll pick another 5. Okay. Okay, so if we try to plot this, 5, 0 says go to the right and then stay. So let's see if we have that on A. A says, go to the right 5 and then stay. So I guess that's about right there. Okay. So I would say that's off to a bad start. That doesn't look like A is an answer just from that right there, trying to plot 5, 0. This one, you do have 5, 0, I believe that's a 5 right here. But then when you're trying to do 5, 5, go to the right and then you go up. Go to the right 5 and then you go up. So you see that doesn't look like it's going to be a solution either. Because look at these. So it's like a B. So 5, 0. So go to the right 5 and then stay. Okay, so that looks promising. Okay. Where's this one? 5, 0. Let's see this. We increase that. And this one does look like it's a 5, 0, right? That one looks okay. And also 5, 5, 5. That one also looks okay. 5. Oh, but then the line though, look at the line. Right. So then I think this one is better. This one, 5, 5. Yeah, that looks like B's the answer. C, I would say no, because see this line there, whereas this is it right here. And you want to do a solid line. So they did do a solid, I can't tell, but it looks like it's a solid line, not a broken. If they had done a broken line, that would not be a good thing. But this looks like it's a solid line. Okay, so it looks like B is going to be your solution from looking at your table. And then as far as shading goes, let's go to your rules. What they say, this is saying all your x's are less than or equal to 5. All your x's are less than or equal to 5. To me, that tells me you want to shade to the left. If all your unknowns, x's, these are your unknowns, and all our unknowns are less than or equal to that. So if I look at this here in your workbook, see this right here, x is less than or x is less than or equal to, shade to the left, see? Yeah, shade to the left, that's what we want. That's what we have. Okay, so yeah, we want to shade to the left, and yeah, they did, see? Yeah, so this looks like this is our answer. And then to do a check, we should always do a check. If we check and we want to use 0, 0 because it makes the math easier, and you see 0, 0 right here, it should give us something true. We should get true. So x is 0, y is 0, and we have x minus 5 is less than or equal to 0. So you put the original inequality, and x is 0 minus 5 less than or equal to 0. This is just minus 5 is less than or equal to, is that true or false? Is -5 a number that's less than or equal to 0? It's not equal to, but it is less than. If you look at a number line, here's 0 and the -5 is somewhere over here. And always numbers to the left are smaller. Numbers to the left are smaller. So yeah, -5 is smaller. So this is true. So you want to shade the side that has your testing point, your 0, 0 in there. I'm going to shade that side, and they did. Okay. Okay, now let's do number 5. So on a test, I wouldn't put something like number 5 on there only because it takes a little bit longer than the other ones, only because it has fractions. Anytime you have fractions, it makes the math a little bit easier, but you probably will have one on your practice because your homework is untimed. So you probably will have one on your practice, maybe not so much on your certify, but on your practice, you probably will. So do you remember what we usually tend to do with these to make the math easier? Because you have fractions, our goal is to try and clear your fractions. I would say that you want to clear the fraction in your inequality. And the way you do that is by multiplying all terms by the least common denominator, which we'll say is 6. Okay, because this side doesn't have any fractions on it. I mean, technically all counting numbers have a magic 1, and so you're looking at 6 and 1, but the least common denominator between 6 and 1, let's see, 1 2 3 4 5 6, see the LCM is between 6 and 1 is going to be 6, right? Okay, so I'm going to multiply both sides by 6. I'm going to multiply this side by 6 and multiply this side by 6. So I'm going to say 6 over 1 times 3x plus 2y over 6 greater than 1 times 6. Okay. All right. And if this is a binomial, so you can't put parentheses there every once a binomial. And if you do it the long way, this is, distributive property, right? The quick way is that you just cancel those out. But the long way is you do 6 times 3x is 18x, 6 times 2y is 12y, and each of them are under 6. Then this is greater than 6. And then this simplifies. Remember, that was your goal, was to clear your fraction, so they should simplify. 18 divided by 6 is 3x, because 6 times 3 is 18. 12 divided by 6 is 2y. So you have 3x plus 2y is greater than 6. Okay. So if you wanted to do the canceling, let me show you over here. You want to do the canceling, you could have just diagonally, see, 6 goes into 6. So you wanted to, you could have done that, cancel those out, and then you would have been left with 3x plus 2y is greater than, and 1 times 6 is 6. 3x plus 2y is greater than 6. See that? So we get the same thing. See? And remember, your goal is to solve for y. You gotta, now that you cleared your fractions, that's the first thing. Clear your fractions. Now your goal is, remember, to solve for y. So I'm gonna subtract 3x on both sides. And I'm gonna put the, remember, mx, you wanna mimic y equals mx plus b. So you want to put the negative 3x first, then the plus 6. Okay, now I'm going to divide by 2 coefficient, which is 2. if it had been a -2, then I'd have to divide by -2. I have to change the direction of inequality, but I'm just dividing by 2. So you have y, and this is going to be -3/2 x. And again, the negative, just put it, you might write it, the negative in the middle of the fraction, but you should push it up to the top. And then this simplifies, right? 6 divided by 2, right, is 3, right? Okay, so there you see, it's a very important. You have to remember to solve for y. On 6, the only reason why we solved for x on number 6 was because you didn't have any y's. So the next best thing is to solve for x. But on 5, you have x's and y's. On number 5, you're going to have a slanted line. So you need to solve for y. So we have to first clear the fraction, multiply everybody by the least common denominator, the least common multiple, which was 6. That cleared the fraction, and then we just started solving for y. And so the first thing you want to do is you want to remember, you want to plot the y-intercept, which is 0, 3. So this tells you to stay and go up. And then we're going to honor our slope. -3/2. So you're going to go down 3, and you're going to go right 2. Down 3, right 2, down 3, right 2. And you're going to do that from the y-intercept, from 0, 3. Not from the origin, but from the y-intercept, not the origin, not from 0, 0, but from 0, 3. Down 3, right 2, down 3, right 2, down 3, right 2. So you go down 3, right 2. That looks like the point 2, 0. Then down 3, right 2. Down 3, right 2. Down 3, right 2, until you're out of grid. And that looks good because see, it's collinear. Collinear means that they're points on the same line. Collinear. Okay, that's a good thing. And if you want it to, you have more grid on top. So if you want it to undo your slope, then right here, instead of going down 3, you go up 3. And instead of going right 2, you would go left 2. If you wanted to undo your slope. And then you would go to the top over here where you left off. Here you have more grid. Up 3, left 2. Up 3, left 2. Okay, and then when you connect your points, this is saying that y is greater than these. Our unknowns, right? Our unknowns are greater than this line. Our unknowns are greater than this line. So that means that you want to shade above the line. And if you look at your notes on this page here, on page 193, it has here, see, let's see, I'll go to the Y, but don't look at the X, go to Y. See, greater than, greater than, equal to, it does shade, the shade above. And that's what we're doing, shading above the line. And this line is a dash, or they call it broken line, not a solid line, because it doesn't have the underscore, it doesn't have a little underscore in anything. That's a dash line. And then you're shading above the line. And then we should do a little check. So we use 0, 0 because it makes the math easier. We should end up saying that we get a false statement, right? Because it's not in the shaded region. So if we use, we can do it. We should do a little check. And if we want to use 0, 0, because X is, because it makes the math easier and it's not on the boundary line, so you can use it. But then just know you should be getting a false statement. And we're going to substitute it into the original equality. 3x plus 2y over 6 is greater than 1. Remember, this is the original inequality. 3x plus 2y over 6 is greater than 1. And everywhere we have an x, we're going to substitute 0. Everywhere we have a y, we're going to substitute 0. 0 times any number is 0. So you have 0 plus 0 over 6 is greater than 1. And so you have 0 over 6 is greater than 1. And remember, 0 divided by 6, that spells on. One spells on, one spells no. One you can divide by 0, one you can't. This is the one where you can. 0 divided by 6 is 0. This is 0 greater than 1. Is that true or false? Is 0 a number that's greater than 1? No, that's false. So if it's false, that means that do not shade the side that contains the origin. Do not shade the side of the line that contains that origin, that 0, 0. And we didn't. We didn't shade the side that contains 0, 0. We did not do that. Okay. So you can see we didn't shade the side that contains 0, 0. We shade the other side. Okay. All right. Okay, now. Let's see. Anything else? I think there was some true or false. Let me look at the true. The last thing I might do is just look at the true and false statements. Sometimes they're good. Let's see. Let's see what they say. This is on page 195. Let's see what they say. There's page 195. Okay, so it says that a solid boundary line indicates that the points on that line are included in the solution. Yeah, that would be true. If it's solid, yeah, you want to include the points in the solution if it's a solid. If it's a dashed line, you don't. Okay. Number 2. If the solution set is an open half plane, and open half plane. So let me look at what they said about the open half plane. This is what they said about the open half plane. If the boundary line is not included in the solution set, then the half plane is said to be open. If the boundary line is not included in the solution set. Okay, so if it's not included, that means you'd have to have like a dash line, right? You have to have a dash line. If you have a dash line, then you could include the points on that line. Okay, so let's see what they say. If the solution set is an open half plane, then the boundary line is included in the solution. And yeah, they said that it's not. See, said that it's not. False. The boundary line is included if the solution set is a closed half plane. So this is this part makes it false. They should have said to make it true, they should have said is not included. The one where it's included is on the closed plane there, closed plane. If the boundary line is included in the solution set, the half plane is said to be closed. So this would be like if you have a solid line, then include those. Okay. So I don't know how important 2 is or not, but it's about solid lines and dash lines, right? Do you include the points or not? I guess that's what they're getting towards. Number 3, the boundary line is solid when the inequality uses a less than symbol. Yeah, that's false. The boundary line is solid if you have less than or equal to or greater than equal to. Yeah. So this is what makes that false. They should have had less than or equal to or greater than equal to. That would make it solid. Because these are for dash otherwise. Okay, so they fix that as false. So dash lines use these ones. Number 4. Would need to be less than or equal to or greater than equal to. All right, class. I'm gonna end this recording. I think what happened is my Zoom is not responding. But I think I'm about done with my lesson, okay?